This is more factoring of polynomials. The first example is the review of perfect squares where there's a subtraction sign. So we want to look at this first term. If I rewrite this first term as 2x times 2x, that's 2x times 2x is 4x squared. Then we can rewrite 81 as a perfect with 9. 9 times 9 is 81. So your final answer in factored form is going to be 2x minus 9, 2x plus 9. The second example in this video is review of the t-chart. You can use the t-chart when you have 3 terms and your leading coefficient is 1. So you make a chart and you say, what are the factors of C, which is 16, that add to B, which is positive 8. So you list all the factors of 16. One of the factors of 16 is 4 times 4. You get 16. When you add those numbers together, 4 plus 4, you get 8. So the numbers we're going to work with are right here, 4 and 4. So when you factor this, read 2 parentheses, split up the x squared into x and x, and you have a positive 4 and a positive 4 from this parentheses. The next example is the review of the AC method. When you use the AC method is when you have 3 terms and your leading coefficient is not 1. So you multiply A and C together. So 2 times negative 15 is negative 30. So you're going to make a chart with your AC. So you're going to factor negative 30 that adds to your B, which is 7. So then you list all the factors of negative 30. One of them is negative 5 times 2. Another one is negative 6 times 5. Negative 30 and 1. So we're listing out some of those factors. When we add these so far, we get negative 13. We get negative 1, negative 29. We're not there yet, so we want to continue seeing if we can find any factors of negative 30 that add to 7. So you could try negative 10 times 3 or positive 10 times negative 3. When we add those together, we get negative 7 and positive 7. So the numbers we're going to work with are right here. So how the AC method works is you remove this middle term in your original expression, 7x, and you're going to replace it with what I just circled, 10 and negative 3. So I'm going to keep the 2x squared, and I'm going to keep the negative 15, and then my middle 2 terms are 10x and negative 3x. So I'm going to go negative 3x, negative 10x. Now what we've done is we've changed this from 3 terms to 4 terms so we can do the grouping method. So I'm going to group the first 2 terms together, and I'm going to group the next 2 terms together, and now I'm going to take out their GCFs. So in the first parentheses, I can take out an x, so I'm left with 2x minus 3. In the second parentheses, we can take out a negative 5, so we're left with 2x minus 3. What will happen if we've done this correctly is my parentheses will be exactly the same, which is my new GCF. So my GCF is 2x minus 3. What's out in front are my leftovers, x minus 5, after I've taken out my GCF.
All right. Thanks, Donnie. Yep.
Next example is factoring by grouping. So we're going to group the first 2 terms together, the next 2 terms together. I'm just going to put a plus symbol. So we take out the GCF of 4x squared, and what we're left with is 2x minus 1. In the second parentheses, I can take out a negative 25, and we're left with 2x minus 1. Just like the last example, the parentheses must match up, but that's your new GCF. Then your stuff out in front are your leftovers. That'll make up your second parentheses. Now we are not done quite yet with this problem. We've done grouping, but we look to see if any of the factors of those parentheses can be factored more. And that's what can happen with this 4x squared minus 25. That is the difference of two squares. So we have 2x minus 5 and 2x plus 5. And then we still have this black 2x minus 1 parentheses.